algorithms like DeepMind's AlphaGo, AlphaFold. We have some advancements that attribute to such a use case. And even in agriculture, we have precision farming, and there's a lot of automation that's happening within the space. For example, drones monitoring crop health. Um, in agriculture, like people might have, and it would be often a hustle for the farmers to monitor, to maintain, to understand the crop health. And drones might be useful for monitoring, might be also useful for various other things like um, helping with pesticides or helping with intrusion, like farm animals might just come in and damage the crops, and drones can have an overlook and then notify farmers, etc. And also in education, wherein probably the last few years has been game changing because of personalized learning and administrative technologies for teachers, professors, and researchers, wherein we have adaptive platforms that can be used uh, in helping with students' needs. For example, I might be lacking in, for example, Spanish, but I might be hard to find a Spanish tutor probably. But now I can use AI, probably just using Google Translate, to convert and learn step by step Spanish, and etc. etc. That's just one use case, and then some students might find it hard to solve certain problems, and the way teachers or professors explain math is different from each other, and probably you can have a different perspective of understanding the math, understanding an equation, or understanding algebra or trigonometry uh, using AI. And another industry that's leveraging AI to the best is finance. For finances in general, insurance, banking, or any of those institutions that has use cases like fraud detection, risk management, etc. And then one of the example is real-time fraud prevention algorithms towards identifying fraudulent behaviors, identifying in how transactions are being made. And I think with the advent of UPI in India, I think you will see there is probably lot of need towards having fraud prevention algorithms being used in the millions of transactions that is happening every second in the UPI world. Oh, by the way, feel free to stop me anywhere. Um, if you all have any questions, I'll be happy to address. And moving on. So let's probably look a little deep into one of the use case. So earlier we've talked about a use case in healthcare, but this is something very close to me because I was part of the team that did solve the problem for in the healthcare domain. So this is called Active Surgical. This is a startup in the US that is addressing medical errors that happen in laparoscopic surgery, meaning surgery where there is minimal invasion. So the the brief is that medical error is the third most common cause of death after heart disease and cancer, usually in surgery, right? And according to a survey, so you will have, there has been about 400,000 plus fatalities by the year end due to avoidable complications. One of that is medical error. And of those problems, 20% of them are the cost of preventing these medical errors is $36 billion. It's huge. It's massive. And Active Surgical has been addressing this problem by building an imaging model, which is basically a computer vision problem, wherein you have a live feed of what's happening in the surgery, and then there is a small tool that you're seeing on the screen that basically captures that feed and then processes it with the help of another system elsewhere, and it basically displays right there on the screen when surgeons are performing the surgery with markings or highlighting what um, the problematic organs, identifying surgical tools, etc., etc. So the one that you're seeing at the bottom right is one of that example. Um, and mind you, this is not the example that you're seeing is probably not a human sample. It was tested on pigs first before doing it on the humans, because the risk of fatality because of a failure of AI system is high in healthcare, uh, and hence it was used tested out first. What it what the outcome here is that it basically allowed surgeons to see beyond the human spectrum. um, while doing the surgery, probably surgeons might have 100 things to think about, and it's easy to for errors, and that can be avoided with simple indicators or signals from a system like Active Surgical. And this system, the use of AI in it, helped them do things better. And um, and it's also a real-time measurement of blood flow that they depict, and that's just one of the outcome. There are like many outcomes as of today. And another benefit is that the digitization of surgery resulted in less error but better judgment, and making surgery intelligent through information. So so the surgeons, they're all data driven now towards performing any surgery. So it's at I mean the stake um, is high, and the impact of AI is high. That's probably what I'd say. And also you have all the leverage, all the information, all the details that you could find about AI everywhere in the internet. But then how do you make sure that you are all you're building something that is beneficial to humanity, right? So that's what we will target in the next discussion. One of the challenges in AI is ethics. One of the problem is bias and fairness. In simple terms, um, AI systems or the machine learning systems are ideally garbage in, garbage out, meaning it behaves the way that it is behaving just based on the data that you feed in. So if you feed in biased or incorrect data, or that has some inaccuracies in the data, if you feed such a data, you will be expecting such an outcome, and that's a big problem. That's one of the major problem with if it's a simple algorithm that's doing linear regression, probably the bias is something that you can understand, you can tune it. But as the algorithms grow bigger and bigger, towards millions and billions of parameters, handling the bias and fairnesses is hard. And this can happen at many levels uh, in the process of building an AI application. Like for example, it can happen. The bias can be uh, at the stage where you collect data. Bias can be when you label your data. Bias can also be when you train using chosen metrics and objectives which are not in line with the problem that you're solving. Um, Bias can be in the production when you deploy, where you deploy. So there might be bias there as well. Bias can see, I mean, users can see the effect of bias. Intuition of AI is different. The way they from their school of thought is different, and the way they use the application is different. So they might be expecting something, but the system might be giving you a different result. There's bias, and it's all. I mean, the many cases where user behavior um, has been a key role, has been a key fact um, in bias, uh, and AI systems can perpetuate biases present in training data, which basically leads to unfair treatment or discriminations towards a specific problem. Um, Another problem, probably we will look at some of the use cases, like in the real world, what had happened. Like if there's any company that has faced a significant by being biased towards something. For example, there was a Microsoft chatbot called Tay, Tay. This was launched in 2016. Um, and the problem with it was that um, it was responding with offensive or hurtful um, outputs, meaning Tay was integrated with Twitter, and then it was interacting with people in Twitter, and it was responding in a way that it was offensive or hurtful to the users. So uh, which was a huge issue, and then they had to shut down uh, this program. And there was another case where in 2018, Amazon introduced an AI tool for hiring, but then um, it was heavily biased, and I mean, the hiring activities, or the use of this tool has resulted in bias against women, and which was largely criticized in throughout the world wherever this tool is being used. And to give you a fact, to give you the landscape of the issues with bias, is that um, 36% of organizations experience direct business impact just because of AI bias, not because they've built something great, but because there's existing bias
Bharat,
in building this model. Hey, Yash.
sorry for interrupting. There are a few questions and call messages.
Yes. I don't think I can see them. Do you mind asking those questions?
Yeah, sure. Whoever has those questions, could you please unmute and go ahead?
Okay, I'll read out those questions. So the first one is by Edward. Considering the high financial cost of error,
Hmm.
how will hospital prioritize investments in advanced tech like this, imaging module to balance patient cost?
Say that again. How will hospitals manage?
How will hospitals prioritize investments in advanced tech
Mhm.
like this imaging module to balance patient cost?
Cool. I mean, this example is not towards. I mean, I didn't understand the patient cost first. I'm assuming there may be two situations where cost of surgery is one for that patient, but that's a different topic. But then in this specific use case, the cost here is incorrect treatment to us, during the surgery, and this is from a patient lens, and it could mean that patient has to go through uh, longer longer times of treatment, and has to suffer, and things like that. These were the common outcomes or issues that patients would have because of medical errors. What active surgical has done is basically understanding like what their feedback is, to the system. As I've earlier mentioned, AI systems are mostly garbage in, garbage out. Nowadays, you have another facet to that, but um, on a high level, so they have adjusted. They have first identified the right data set, the right supervision of right labeling that had done on top of these images. So that was done at a very large scale, wherein the people who were tagging these images or videos have some background in healthcare and surgeries, and some of them are doctors even. So that's where the user bias, the data bias has been controlled, and also the labeling bias has been controlled. And another way that you can also protect patients from medical errors within the active surgical spaces, they have tried to identify and see if you can have explainability of these models, of these deep learning algorithms, in use. And it's a very, very hard problem. Explainability is a big domain within AI, and but then there were some measures in addressing why um, certain image has been marked or segmented with this one, and being categorizing it as spleen versus liver, or identifying or segmenting surgical tools versus human organs in that imagery. So that's also one thing. And another way they have better estimated is by using uh, the appropriate metrics of evaluation. It can be at the algorithm level, it can be at the system level. Everything is statistically tested to make sure uh, bias is controlled. This was how it was done in active surgical. I mean, there can be many ways, but then one of the ways.
Excuse me, sir.
Thus,
So
yeah,
I
go ahead.
think the question that Mr. Young wanted to ask was that AI is currently, what AI is that there's high financial cost of incorporating it into healthcare.
Okay.
So
Mhm.
that will affect the patient's bill, or the affordability of the patient. We'll end up paying more. So that is what the person wanted to ask, I feel.
Okay.
So how do we tackle that?
So there is there, there are 2 to 3 different ways. Um, when you say cost of incorporating these systems in healthcare, for example, the cost can be in acquiring the data, right? And another cost can be in training algorithms on top of that data set. And so training and acquiring data is not the end, right? So there'll be other cost factors as well, like using them in real time, using them in the real world. How do you use them? So where do you launch your AI applications? What is the compute power required to process these images or videos, or um, you know and how do you um, send the response? Like if you request something to this AI, it will respond something back. So how do you address the latency aspect as well? So all of these areas is where, I mean, infrastructure is one, and all of these are some of the areas where you can reduce costs. um, Probably a couple of years back, we may not have like the huge compute power, but now we do. The training cost is where I think you can have a control. That's one. But I think in the domain called something like healthcare, labeling is something that you probably may not want to avoid. Handling issues in data collection and data labeling is, I would say, uh, let's probably have that cost, because um, health is something that you can't uh, put a price tag on. Um, and another way you can reduce the cost is compressing these algorithms. So once you've built, let's say you're using ChatGPT, something like that, and you built it on your own in a healthcare domain. and the cost can be high. So you might want to reduce the cost of inferencing as well. Some of the techniques like compression or quantization of these algorithms might help you there. Meaning, previously when it was 175 billion parameter model, now you have condensed that information, condensed that learning towards a smaller algorithm that can be optimized towards addressing a specific use case. You're somehow converting your landscape of AI from a generalist to a specialist. So you have a clear control over there. That's something that you can optimize cost. And yeah, I think in the future at least, so we will see a lot of research or improvements in the infrastructure space as well. um, AI is not the only space that is evolving. So we have other spaces like data engineering, cloud, edge devices like GPUs, or edge devices like NVIDIA chips, or all of those, and processing using AI. So we probably have GPUs now, but then we also have tensor processing units, TPUs, and some of that cost can be optimized as well, depending on the payload. So all of these can be done to address the cost. And if you do all of this, uh, for the patient, uh, probably it might be a factor, of cost reduction. On top of it, um, the usual costs of surgery or consultation with doctor, or any of the services might be a different story. Did I answer the question right?
Yeah. There are a few more questions that you might want to answer.
Mhm.
One of them says, New Cat Mad Dog says, so AI is good at casual racism.
Casual racism. Okay.
We
What
could
was
just skip that one. And Chloe asks, but who will be held accountable if AI is targeting a specific goal?
Yeah, we will talk about that um, going further. I've set up some slides on it.
All right.
Here's
Yeah,
another
there's one
by
more by
Tanushya.
Tanush Shyam.
How do you
How do you
think
think
quantum computer
quantum
will?
computers would affect AI?
Yeah.
Oh, that's a cool question. Um, I think quantum computing um, is an entirely different paradigm shift. The way we see things, right? Um, and information processing capacities that the current systems have, with the binary, zero or one data. Um, so that's an entirely different way of using compute, and how quantum computing has. The benefit for quantum computing is, so we can go at the grassroots of how information is being processed. Like if you have like a few bits of information, how is that processed in using a quantum computer. um, there's another topic called quantum machine learning as well. So all the algorithms that we have, for example, uh, some algorithms like machine learning, in the supervised learning, for let's say linear regression, right? The way we have written out that algorithm is different compared to how it would be in quantum machine learning world. So the algorithm by definition will be changed, and there is a lot more possible. It's no more number, but you can think about distribution as an input. What I mean by that is, like, if you take a distribution, you have a mean and standard deviation, right? So whereas now, let's say you have a row column data, probably you'll just pass in a series of numbers and then ask the algorithm to predict something. But then with the advent of quantum machine learning or quantum computers in the space of AI, you can look at distributions and learn from distributions as one or more single inputs. Um, and if you look at also the chips that we have for quantum computing, the way they're built are also different. So it's always a the Schrodinger cat reference, wherein once you close the box, there is equal chance of having the cat inside the box and probably not. So that probability is where I think the key difference is. And yeah, I mean, I think recently Google had launched Whisper, Whisper is one of the supercomputer. I'm unsure at the moment if it's quantum or not, but then it's probably had similar principles, and it was able to achieve what was not possible, what was supposed to be like a million year computation. It was able to do in minutes. So now we have all the algorithms, all the models, all the large neural networks. Imagine all of them being, you know, translated in the quantum space, like applied in the using the quantum computing methodologies. So you have faster, uh, controllable AI that is that will be advanced, probably human level. Any further questions?
Right, Bharat. I think the questions are done.
All right. So I'll go ahead with this one. So we were also, I think, yeah, we were closing out on bias and fairness. So I'll probably move ahead. So another challenge in AI is privacy. Um, Privacy meaning personal information or um, unwanted personal data being used by the AI, or personal information that is being um, given out as an output, or um, there are many such concerns. One of the challenges is in the minimization space. So usually what people do is we try to minimize some of the information demographics or private information, and there was um, another problem which is around de-identification, anonymization, um, while you train your model and while you use this algorithm in the inference stage, and you might not have control at some point, unless until you have a guardrail system in place. And sometimes data might be shared with third party, and you may not have control on that data. Some of that information might have some privacy related information, personal information indicators, etc. And transparency, in terms of decision making ability of these AI models also is a challenge. The challenge is also around the regulatory compliance. For example, GDPR. Um, GDPR is the AI policy related to personal information, which was introduced in the Europe, and that plays a key role in addressing privacy and personal data being used. I mean, probably a few years back, there wasn't much of an emphasis on these concerns, but then lately, this has been the core, um, you know, aspect, which is tied to uh, legal teams, and this is where I think the lawyers and attorneys play a part. and also the product folks and the executives, all of them sit together along with the data scientists in figuring out what are some of those privacy concerns that needs to be addressed in their existing systems or in the future AI use cases. So largely the collection and use of these data sets raise questions about users' consent and protection of these data sets. So this is a very huge problem. It's also interesting because there might be some information that may have helped certain AI tools in the past, which were unfortunately private information. But then I think there is research around masking some of those personal information, and even with the masked information or redacted information, how can you build better AI systems? So that's also you know um, one of the great problems that we have in the world of AI. Excuse me.
Bharat,
Um, yeah.
Mr. Devaraj has a question.
Mhm.
What are the inherent limitations of AI?
Say that again. Inherent.
Inherent limitations of AI.
Um, what do you mean by inherent limitations? Are we looking at a specific uh, problem, or in general AI, or like are we looking at a specific use case or something?
I assume he wants to ask about the normal AIs, like for example, ChatGPT. What are their limitations in general? Yeah.
Okay. Okay. AI in general, uh, one specific limitation can be the way it's built. For example, GPT-2 uh, is GPT-3, or for that matter, um, was earlier largely limited to text. So it wouldn't understand images because it wasn't fed with image data. Just I think it's pretty simple to understand from the garbage in, garbage out philosophy, meaning your AI is what you feed, right? So that's probably one key limitation. But then nowadays, most of the AIs are multimodal and can interact with a lot of different types of or formats of data, be it image, text, video, etc. So um, that's one, and it's also limited by the compute power that we have. For example, procuring, let's say if you were to build your own AI, or if you're building an AI system for to address a specific problem, right? Um, so you may be limited by the compute power that you have access to. You may also be limited by the funds, or the cost of training the algorithms, or building these algorithms pipelines to support them, etc. Um, so that's also one limitation. Another limitation can be the infrastructure. For example, you may have built, let's say, a model that's about 5 GB of size, for example. It might have millions or billions of parameters, but then let's say if it's a 5 GB of large language model, some variation of large language model, maybe. Um, if you cannot process the inference by feeding certain context or certain input query or something, along with different formats of data, um, so you may or may not have the processing done uh, within the expected latency. That's one limitation with respect to infrastructure. Another limitation can be the context windows or the token sizes of some of these AI systems. For example, if you may have experimented this, probably on uh, GPT 3.5 Turbo or any of those similar LLMs, similar size LLMs. What happens is, let's say, if you've been interacting in one chat window, and then you've kept on asking questions, and it's been giving you responses, paragraphs, and images or whatnot. After a while, probably the context window limitations are reached, and this was an issue that some users faced when ChatGPT was launched. But after a certain point, you have like enormous text, enormous exchange of messages between the user and the model. If you were to ask another question on top uh, to the same system, like given all the context of previous chat, it would sometimes not process or omit some of the information. Um, of course, there are ways to overcome that as well. Like you can condense the information, but again, you'll have to build another layer on top. But the but yeah, token length or the context window that the system is built on is probably one of the limitations. Um, Another limitations is um, it's probably not like a limitation, but then the way you design the system, let's say if you want to address some privacy concerns or some any of the ethical challenges in AI, so there's a limit on you yourself defining that limitations and addressing one by one. So let's say you build a system, um, uh, and you want to make sure that it isn't biased towards gender, for example. You may give certain instructions to the LLM, tune it, or maybe retrain it, or uh, build another layer of approval that is needed on top of these LLMs, or you build RAGs or you build agents, all sorts of things. But the way you define it matters. Uh, at this current juncture, I think um, not all people have the required knowledge or required information if they were doing certain benchmarking, certain uh, you know limiting the system towards responding in such in a expected fashion. And not all of the people are well versed with the AI world or the internals of the AI systems. So some of those can be limitations as well. So you may have addressed the gender bias issue, but then there might be age related bias. So you will have to go again and then redo it. So it's an iterative process, um, where you identify issue and then fix them. And sometimes you may have clear guidelines, like you might have a bible of like every problem that you might see. You might list it down for a specific use case. For example, if you're building a system for customer service in banking, for example, you can limit your you can limit the way it responds, and confine it to talk in the banking language. uh, that is there, but then limitations around ethics, privacy, all of those are like current challenges. um, so that at a human level, or the design standpoint, so we still have a um, long way to go. Any other question?
That's good for now. We could schedule a small question session at the end of your keynote speech.
Yeah, yeah, that works. Do I have how long do I have now? um, I think we have a
How about
schedule.
25 minutes?
Okay, cool. Awesome. So let's probably go ahead and then, given the time, we can discuss questions.
Sure.
So, yeah, so we were discussing some of the use cases, some of the cases, or some of the issues that happened in the past with respect to privacy. And then one big um, issue that happened was with Cambridge Analytica and Facebook scandal, or some people call it scandals, some people call it misuse. Yeah. So what happened is, I think during the Trump's campaign, so there was the acquisition was there was a misuse of millions of Facebook user data, um, and that has led to Trump's victory. So there was all this uh, issue, and then and there was a whistleblower from Cambridge Analytica to point out this. So that's one like uh, noticeable, or any issue that is related to privacy that can be noted. And one other issue is when OpenAI's internal AI data is stolen, and there was a 2023 breach of the data. So that's also a privacy. Uh, I mean, there might be some private information of the company itself, or the company that is using. I mean, that they might have their own data set. It can be any other details, like their future plans for the algorithm, or the algorithm. The uh, the flow of algorithm, the design of the algorithm might have been stolen. I mean, might have been breached. So that is also a privacy concern. And yeah, I mean, one of the studies from KPMG says that um, while consumers recognize AI's benefits, at least half of them believe it makes it harder to protect personal information. And I think it's still true. This was studied in 2022, I guess. And I think it still holds true. Maybe not 50%, but then at least 30 to 40%, whoever's using uh, using these AI systems, they have a concern about their personal information, especially let's say health records of people, or personal details, their background, or their demographic details, or um, of their personal lives, any of that. Social media is one. There's I think there's a whole frenzy among certain group of people around privacy, whether or not to put or publish or share their information in social media. And I think um, that's also a major problem to be addressed. And there's another challenge as also, as one of the hackers, I guess, was pointing out, on accountability and responsibility. That's also a big challenge. Uh, you know, um, Accountability, as in, who do you address when there's an issue, like when AI is behaving in a way that's harmful to the users, or AI is not behaving as per the expectation. Who do you held accountable, or uh, how do you build a system where you have certain metrics to identify uh, where it went wrong, or how it went wrong. All of those things are challenges in AI, and to the date, I think we may have addressed some of them with processes in place, with research backed, identification of certain rules that you'd want to implement, certain design patterns of building these algorithms. um, and it's still an evolving space of having a full and reliable things to address, or how do you make yourself accountable uh, towards AI. Often when you build an AI system, it's not just the data scientist that builds the system, right? In the enterprise, I guess there'll be a lot of teams participating in building such a system. Of course, leaders in the industry will have their part, but then there can be people from the product domain, people from the software engineering background who are developing this applications. People can be from the data background in the engineering or in the cloud space. People can be you and I who are building algorithms, um, um, and people can be the policy makers, or the organizations as a whole. So all of these um, people will have to come together and then uh, discuss who was accountable for what, responsibly responsibility being split, shared, or how do you mitigate certain issues, right? So all of these needs to happen um, with people in place. Like at best, I think best case scenario is like when you do all of these, like before building or before solving a problem, if you were able to address this, then probably you will have a better control on the system, rather than sorry rather than figuring out what needs to be done later. One of the example is self-driving car accidents. So you might have seen certain cases where um, there were accidents, even though companies like Tesla promised certain benchmark of performance. There still have um, people have met with accidents, and in some cases fatality. But then who would you held responsible for? So I mean, it's all in the question between lawmakers, industry experts, um, the that build systems, and everybody's involved. Yeah, a few examples is when yeah, Tesla is one, and the Uber also had tested out a self-driving car where driver pleads guilty to endangerment and pedestrian death case. I mean, this was um, identified with Uber. Um, who would you held accountable for such an issue? Is it the driver? Is it the vehicle? Or is it the algorithm? Is the one that you developed? So all of that. So clear definitions of variance, understanding what researchers are saying, and also understanding what rest of the world is doing. If you're building something similar, some similar AI application that has already been done, so addressing and learning from all of those would give you a better picture of what needs to be done. And it would be beneficial if you could do it before even the design phase of the system. Yeah, one of the challenges is that, for example, in these self-driving car cases, these algorithms being black box systems, meaning um, there is probably less explainability, or you know uh, root cause analysis, which neuron made that decision, or which part of the algorithm was broken. So all of that information seems hard to find, and often a lot of systems, a lot of companies fail to do that. And where explainability X AI plays a key role. And as I mentioned, shared responsibility, and then having governance across all the frameworks that you build, both on the algorithm front and on the infrastructure front, um, on the whole, the reason behind building the DAG. So moving on. So I think it's fair to address, like, um, or you can you need to also think about like what should AI do, like define what it needs to be done. Meaning, don't just probably use AI just because you can, but use it responsibly. Use it to address a problem uh, with a confined action to it. So this was coined by this quote has been said by John Havens. He's one of the exec directors of IEEE. And yeah, I mean, as I mentioned, like one of the example is like when we are solving a problem, for example, call centers, right? So you might use some insanely new AI technologies, like you might use voice AI assistant, you might use large language models, you might use um, large vision models, like having like all sorts of complex large black box models. But then what's from a data or a product perspective, um, you may need to have you may need to have to ask the right questions and address them. For example, what does a great product look like in a call center domain? So the ideal goal is to have probably reduce the call center goal costs, right? So if your motto is around reducing costs, you may not need all of those fancy algorithms or large models, large AI systems. So you may have to probably start with understanding the problem first. Second, identifying what is the easy way to do it, what is the hard way to do it, what would be the cost around it, building things, and what frameworks we have to deploy towards building that system. For example, the accountability and responsibility aspects come in, the privacy concerns come in. All of those take place. All of those needs to take place before you start to work on a problem or like go with a specific design, right? So um, all I say is use AI to solve a problem holistically rather than immediate symptoms. Uh, that's I think it probably works out in all the problems that we are seeing in the world. Um, yeah, so that's pretty much it about this. Um, Addressing a problem with the intent to solve. And as I mentioned, like one of the framework, as we were discussing earlier, is about having a framework to be responsible in building AI system. And key topics or key modules that you need to consider is how transparent is this model, how transparent is the response, like um, how transparent are you in building the system with your stakeholders, your peers. So all of that comes in, and also how fair is the data sourced, and how fair is the algorithm performing, and who are you held keeping accountable for, who is responsible for what, and how are we protecting private information of users, of the data, uh, of the people's data or information that you've used in the uh, data preparation, training phase, all of that, and how sustainable is the system, and how safe is the system. Meaning, you'll have to identify who is using your AI. Probably, if you've built something, there might be different user personas or user age groups or user um, different people that you'd want to target. But then you may have to make sure um, if it's being accessed by somebody else that who are not supposed to be using this app. So safety is one, and how reliable is the system. So you probably have to have guardrails for your AI system, and make sure you monitor performances of the system, constantly update or upgrade your algorithms and tune it towards addressing some of those issues that you see once you build. And and also how can you build trust among your stakeholders whoever is involved in the building of this AI system, and how would you um, uh, make sure you translate that to the users, right? So how do you make sure you explain to the users that this system is reliable and it would respond in a set behavior. It wouldn't go in incorrect directions. So this is probably something that you would have to do. You will have to do um, when you're thinking about using AI to solve a problem. Yeah, I mean, on a fun note, um, make sure just make sure there's always a human element to AI. So all of this that we discussed, privacy, the ethical challenges, and everywhere, right? So you can't just train a model and leave it, right? So uh, probably you'll have to make sure that there is a human aspect, make sure that AI is being used responsibly, and then it's addressing the problem that you've intended for it to solve. Yep. And I'd also say you'll also have to in the future in 2025 or like going forward, probably you'll have to interact with machines day in day out. Um, and to what extent you need to interact with these machines, to what extent you will have to know about these AI is important. And I think AI education, irrespective of what you do or what background you have and um, what stage of life you are in. So probably you'll have to be accustomed to some of these tools because it's probably everywhere. Every screen that you see probably has some aspect of AI. So, for example, in healthcare, AI assists doctors in diagnostics by analyzing large data sets. Cool, but humans focus on validating those and then apply the insights that they see. So AI might say something. It might be an information that you can consume, but then think before you use that information, um, and and that's the human aspect. Um, in creative industries, for example, generative AI tools like helping artists and musicians, writers, explore new creative dimensions. Meaning, like you give a prompt and then it'll give you 10 different ideas, and make sure that it's your idea. Use it to have a better process of creating your art, but then make sure it's uh, something original, something. Make sure there's some human component in it. I mean, for sure. I mean, there are others who say, I've built a model entirely in certain way because I have, and then to be created. I have fed it my persona, my sure, it still has your human aspect because you're the one who controls it. And yeah, manufacturing, education, same story. And then it's basically everywhere, um, that you'll have to make sure there's a fair component of human and machine interaction. With that, I'd also um, say that um, my recommendation is that you go ahead and solve problems innovatively. You can innovate boldly with like crazy ideas and then explore what's feasible, but do it responsibly. Um, and the simple statement is just because you can do it doesn't mean you should, because there might be a ton of different implications of using it. There might be cost aspect. There might be environmental aspect. There might be privacy aspect and a lot of other things that fall into the case when you are building an AI system. And I I'm a believer in democratizing access to these tools to everybody. Um, uh, I believe in open source, so I guess that's a personal take. Um, and also build a future that benefits everyone equitably, meaning everyone are the residents of this world. Let's make sure uh, everyone has access to this, and everyone gets benefit out of these AI systems. Cool. With that, I think I'll end my session, but then I guess we have some questions that I can address. If Yash, I'm not sure if we have some time, but then let's see if we can address some questions.
Yeah, sure, Bharat. We can have 5 or 10 more minutes.
Got it.
The first question is by Vishnu Jyoti Gogoi. I'm sorry if I spelled that wrong. Sir, we know that many of the jobs out in the market are being replaced by the usage of AI. So
Mhm.
what will be some of the new jobs that will be available in the market, and what skills should we hone that we can stay up to date with the pricing technology?
Sure. Um, I'd like to give an example that was done in the past. This has no relation to AI, but then earlier, I think decades ago, probably there was no invention of calculator. There was no invention of Excel, right? How do you think people, mathematicians, financial experts, accountants were able to calculate or do the math and then function, right? So they still have the inherent knowledge of how things work. They are experts in their domain, but then having this introduction of calculators or Excel or any of these software or computer applications, did they actually replace them? Probably no, because it those tools may have enabled them to do things faster, to do things better, and probably have best use of their time in various other things in their lives, right? So similar to that, I think AI, as much as we're seeing whatever systems that we are seeing at this moment, probably you can use them to your convenience, to your to make your life gets easier, sure. And I think that's where people are headed as well. And with respect to skills, I think let's say 2025 or the next 5 years, next two years maybe. Um, I think I'm not entirely sure if I can use the word replace as what's going to happen to jobs. Um, but then people who were doing, let's say, accounting at this moment might do something else as well in addition to accounting. They can be doing, um, uh, for example, um, they can be doing another. Um, they can have multiple other things that they can explore. Um, Maybe creative in the creative aspects, or maybe in the or an accountant need not be an accountant all the time, so they may have options to do or handle finance applications, or build financial tools, probably use AI there as well. So you will see a shift in what people are going to do. I wouldn't say replacing AI replacing jobs. So for example, for software developers, right? Nowadays, I think a fair bit of organizations are using Copilot or any of these AI systems. Um, they may not probably entirely replace their workforce, right? So they might look at these tools as effective coders, sure, but then at what scale? What is the cost of having these systems at an enterprise level? So probably the language is something that still holds true, that you'll have to have the language skills. But then in the future, probably while using these AI systems, you will be a better um, person understanding language. You'll have better language skills, and that's probably much more valued than Python or C sharp, C++, any of those languages. uh, Valued as in most used in the sense. um, another skill could be judging how in decision making. So for example, like if there were 10 people doing one job, like working on a project or so, for example, now there might be maybe some of them will have time to focus on another project or another, explore another domains, explore another problems to solve. Some of them might have to use these systems, and then make better decisions. um, and things get faster in terms of development time than it used to be earlier. So everyone can be a coder, although you may or may not know coding. So you'll have to be adept in your general life skills or soft skills. So probably AI may not take away, or may not dominate in the soft skills, or the way you're interacting with people. So all of those things will probably remain the same, or maybe get better. So that's probably my take uh, on that question. I mean, people have different opinions. There's just one.
All right, that's it. We have two more questions now.
Hmm.
One of them is pretty innovative, I would say.
Hmm.
Hey, since you work at Starbucks, do you drink Starbucks every morning or make it
Keep the
yourself?
troll questions,
Or
please.
probably a local barista?
It's a troll question. Please leave that.
Yeah, sure.
Go with the question of Abhiraj Chetia.
Don't you think that this lack of transparency will erode customer trust now that AI is embedded in everyday software applications? And also, even a small bias or privacy violation may lead to significant societal consequences.
Um, it all depends, as I mentioned, the framework of how you're developing the system. A good governance of the system will lead to better AI products. And problems can arise in different areas of AI. But then if you have a framework that you have built around for a specific use case where the impact on the customers is minimal, that's probably how you'll have to build your systems. So as I said, like, um, do we really need AI to solve probably all problems? May not be, right? So in some cases, for example, um, you might not need AI, right? So you probably need certain rules in some certain situations. Using AI there might be an overkill. Um, so maybe use a simple logic to solve the problem. And in some cases, you'll have to know when to use what algorithm. As a developer, you'll have to know when to use what, and you'll have to also understand the um, advantages, disadvantages of using a certain algorithm. What is the pros and cons of it? What is the assumption that the algorithm makes when a simple example is like linear regression basically assumes that the data is linear and then builds it, right? But data in reality is non-linear. So you'll have to know which algorithm you're using. I mean, I've simplified the example, but then even with the large models, large algorithms, you'll have to know and understand the integrities that goes in towards building the system. So that way you have a control. That way you can say that there's probably not a reason for using that system.
I think with that, let's conclude that our session because there are no other.
All right. But feel free to reach out to me. I'm on LinkedIn. You can find me there, or I'm reachable on the Discord as well. Um, um, yeah. Any questions? Just shoot over to me, and then I'll answer to my best. And all the best to all the hackers. I hope. I'm guessing that you will have some of you might have um, used some sort of AI in your hack. I look forward to it, and also, please make sure that you're knowing. Make sure that you know what you're doing by using a specific AI. Be mindful about it, and also make sure that you know the outcome, or you expect a specific outcome just because you have a specific input to the system. I mean, make sure that you know both the ends, not just use ChatGPT or any of these uh, recent algorithms that does the job for you. All right. Over to you, Yash. Thank you for the opportunity. Thanks for having me, and thanks for letting me share some of my insights, some of my understanding of what AI is. I look forward to talking to you all uh, over Discord or LinkedIn or wherever feasible.
Yes, that is happy.
Much
Thank you
for
for your
your
time.
insights and into this fascinating world of AI. Your
Thank you.
expertise has helped a lot of our hackers. And on behalf of everyone present, I would like to thank you for enlightening us with your knowledge and experience. We wish to see you again, and I believe some of our hackers will contact you.
Cool.
Yeah.
I look forward to. Thank you.
Thank you. Everyone, you can leave now. This will be the end of the opening ceremony. Thank you all for being here.